Okay, next we'll study acceleration. Okay, what is acceleration? So, as I said earlier, we have studied distance, displacement, speed, velocity. Now we study acceleration. Okay, acceleration. Acceleration is actually we define a rate of change of velocity. Okay, rate of okay rate of change of velocity, or we can say that change in velocity upon change in time, that is acceleration. We define a acceleration. This also has some average and instantaneous. So average acceleration is change in velocity, that is delta v upon delta t. Okay, that is average acceleration. Next is instantaneous acceleration. Instantaneous acceleration is like if time difference is very low, like limit delta t, if it is tends to 0, that is dv by dt. This is it, average instantaneous acceleration. We have two types of acceleration. One is average acceleration and one another is instantaneous acceleration. If we go to the graph of velocity and time, so slope will represent the acceleration. Okay, slope will represent the acceleration. This is a slope, so you can find out this is the theta, so tan theta will be acceleration. Slope of the graph will represent the acceleration, and area under the curve will represent the displacement. Okay, so area under the curve means, suppose you want to find acceleration between this and this point, so area under the curve we can say that it is, so this red part will represent displacement. So if we could move graphically, a graph of velocity versus time is given, then its slope will give you acceleration, and this area under the curve will give you displacement. Okay, so slope of the curve will give you acceleration same as velocity and speed. It has also some average acceleration and instantaneous acceleration. Average acceleration means we are calculating acceleration over 2 point and time distance is large. Instantaneous acceleration means we are calculating small time span, so time difference will be very small, and that is average acceleration, instantaneous acceleration. Okay, now we see a motion with constant acceleration. Okay, motion with constant acceleration. Okay, motion with constant acceleration. What happen when the acceleration is constant? Acceleration is constant, or we say that acceleration is a. So what will happen if motion is constant? Then we have three equation to calculate the all other parameter. Like suppose a body is moving from one point, that is position vector r1, to other point, that is position vector r2. Okay, this will be its path, this is P and this is Q. So its displacement will be, as we said, r2 minus r1. At point P its velocity is u, and at point Q its velocity is v. So we will have, and total time taken is t. So we will have three equations to calculate the parameter. First equation we calculate is v equal to u plus at. Okay, u plus at. V is the final velocity, u is the initial velocity, and t is the time, a is the acceleration. From where it comes from, as we know that acceleration is a rate of change of velocity, so we can write that acceleration equal to v minus u by t. So t will go this side, so we can say that v minus u equal to at, and v equal to u plus at. Okay, second equation will find out when acceleration is constant. We'll see that r2 minus r1 equal to ut plus half a t square. Every expression you should know here. Every r2 is the final position, r1 is initial position, u is initial speed, a is acceleration, and t is time. Okay, so we just write it down side by side. r2 we write at final position, r1 we write at initial position, u we write as initial velocity, and t we write as time, a is acceleration. Okay, just keep in mind this formula we can use only when acceleration is constant. We cannot use this formula anywhere. Okay, when acceleration is varying, then we cannot use this formula. Okay, next.